Today's video is on integration using residues, and today's integration is of the type minus infinity to plus infinity f of x into dx. And here the integration is around the contour, which is a semicircle. And now I am going to use the residue theorem to evaluate integral 0 to infinity dx by x power 4 plus a power 4. And this is the closed contour, so which is a semicircle with center 0 and radius r. And I'm going to explain you each and every bit here. So using this contour integration, so the distance from 0 to infinity is same as the distance from 0 to minus infinity. So I'm writing, in order to calculate from 0 to infinity, I am going to write this as half times of minus infinity to plus infinity. From minus infinity to plus infinity, it is half, which is 0 to infinity. So 0 to infinity, I am changing it as half times of minus infinity to plus infinity, and this is same dx by x power 4 plus a power 4 and dx by x power 4 plus a power 4. First thing, I have changed this one to minus infinity to plus infinity, as it is very needed using contour integration. So we have to consider integral c f of z dz, where C is a closed contour. So C is a closed contour consisting of a semicircle CR, that is mod Z is equal to R. That is, mod Z is equal to R is nothing but it is a circle. It is a semicircle with center 0 and radius R, together with the real axis minus R to plus R. See, I am going to explain this one. So this is the total integral. So we have to calculate, this is the total contour where C is a closed contour consisting of a semicircle. So this is the semicircle. Semicircle, that is mod Z is equal to R. So which is equal to, so this is a semicircle with center 0 and radius R. So this is radius R together with the real axis. So this is nothing but the real axis from minus R to plus R. So this is the contour description, and we have to use this closed contour, and we have to find out the poles and residues, and we have to apply in residue theorem. So for that, see here the total integral, the total contour f of z into dz can be written as, the first thing here is from real axis, that is minus r to plus r. So this is, so see these arrows from minus r to plus r, minus r to plus r, as this is the real axis. This is f of x into dx plus this one. So this is the curve, the semicircle curve, so which is equal to, this is a CR, this is f of z into dz. So in order to calculate this one, so we have to add up these two. So meanwhile, see what is f of z. So f of z is nothing but, so f of z is nothing but this is dz by, see here from this, so this is dz by z power 4 plus a power 4, z power 4 plus this is a power 4. And clearly, in order to find the poles, what we have to do, so we have to equate the denominator to 0. So if I equate the denominator to 0, this will be z power 4 plus a power 4 is equal to 0, and therefore z power 4 can be written as minus of minus a power 4. And here I am shifting this 4 to other side. So this will be z is equal to minus a power 4 whole power, this is 1 by 4. And see, z is equal to, this value is a power 4 power 1 by 4, and this is minus 1 power 1 by 4. Now I can cancel this 4, and z value is equal to, this is a times of minus 1 is nothing but cos 180 degrees. Cos pi is minus 1 plus I sin pi, so which is equal to 0 power, this is 1 by 4. And now our poles are, so a can be written as, so this can be in general written as a times of, this is cos 2n pi plus I times of, see here, I times of, this is 2n pi plus pi power, this is 1 by 4. So this value is 1 by 4, where n value runs from 0, 1, 2 and 3. And see, this power 1 by 4 can be written as, see here, z is equal to, this is a into, this is cos power, this is 2n pi plus pi by 4 plus I times of, this is sine This is 2n pi plus this value is pi by 4. Clear? This is pi by 4 where n value ranges from 0, 1, 2 and 3. So if I keep n is equal to 0, what happens? If I keep n is equal to 0 here, this will be, the z value here will be a times of, so if I keep 0 here, so what is the pole here? That is cos pi by 4 plus I sin pi by 4. Here n is equal to 0, this will be pi by 4. And next, see here, if you keep n is equal to 1 in this, so if you keep n is equal to 1, see what happens? Z is equal to a times of, this is cos, if you keep n, this will be 2 pi plus pi, so which is equal to, this is 3 pi by 4. Clear? And here if you keep n is equal to 1, so this will be sine, this value is 3 pi by 4. Clear? And next, if I keep n is equal to 2, keep n is equal to 2, then z value becomes, z is equal to, this is a times of, this is cos, 2 2s are 4, 4 pi plus pi, so which is equal to, this is 5 pi by 4 plus I into sine, this value is 5 pi by 4. And next one, if I keep n is equal to 3, so if I put n is equal to 3, what happens here? Then z value is equal to, z value is equal to a times of, this is cos, if I keep 3 here, 3 2s are 6 plus 1 7, so this will be 7 pi by 4 plus I into, this is sine into 7 pi by 4. So these are all the poles here. So among these poles, we have to check whether these poles are within the contour or on the contour or outside the contour. And let's get started to find the values of these. As you know that, as it's very simple, as you know that cos 45, so pi 180 by 4 is 45 degrees, cos 45 degrees is 1 by root 2 and sin 45 degrees is also 1 by root 2. See here, the first, after keeping n is equal to 0, we got this one, so cos 45 is 1 by root 2 and sin 45 is 1 by root 2. So this will be 1 by root 2 plus I times of 1 by root 2. The first pole value is this one. Z value, the pole value is this one. So after keeping n is equal to 2, we got, so here it is cos 3 pi by 4 plus I sin 3 by 4. So coming to this, we have to calculate this value. So this 3 pi by 4 can be written as pi minus pi by 4. So pi minus pi by 4. What is 180 minus theta? Here 180 minus theta, here sine value is positive and cos value is negative. So cos value, this will be minus cos pi by 4, and for sine this is positive value, that is plus I sin pi by 4. As you know that pi by 4 value is 1 by root 2. Clear? So this is the second pole. And the next one, after keeping n is equal to 2, this is cos pi by 4 plus I sin pi by 4. So pi by 4 can, 5 pi by 4 can be written as pi plus pi by 4. Sine of pi plus pi by 4. So what is 180 plus theta? So coming to this 180 plus theta, tan and cot are positive. So tan rest are negative. So cos will be negative, that is cos minus cos pi by 4, and this is also negative, that is minus sine pi by 4. So these two are the negative values. So this is the third pole. And after keeping n is equal to 3, z is equal to a times of cos 7 pi by 4 plus I sin pi by 4. Clear? 7 pi by 4 can be written as 2 pi minus pi by 4. See, 2 pi is nothing but 360 minus theta. So this is also sine 360 minus theta. Coming to this, here is 360 minus theta. Here cos and secant are positive. So here cos value is positive, that is cos pi by 4, and the rest are negative, that is minus I sin pi by 4. Clear? So this is 1 by root 2 minus I times of root 2, and this is our fourth pole value. So we got all the pole values ready. So using this trigonometric table, and it is also very important. And see, the first pole value can be written as a times of cos pi by 4 plus I sin pi by 4 can be written as, so cos theta plus I sin theta can be written as e power I theta. So z value is this one and the pole value is this one. And second one can be written as a into e power 3 pi by 4 I. So the pole value is this one. And for, 3 pi by 4 I. So the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi by 4 I, so the pole value is this one. And for, 3 pi third one, that is z is equal to a into e power 5 pi by 4 I. The pole value is this one. And the next one, the fourth pole value is this one. So we have to check whether these four poles are within or on or outside the given contour. So what is the contour here? The contour is nothing but the semicircle with the, along with the, together with the real axis from minus r to plus r. And this is a semicircle curve, and we have to check. So let's get started to check this. So initially this is 0, so this will be 1 and this will be minus 1. So this is imaginary part plus I and this is minus I. So here if you see, this is 1 plus I. So 1 plus I can be written as 1 and I. So this is 1 and I. So this is 1 and this is I. The point is inside. And this is, the next one is minus 1 plus I. So this is minus 1 and this is plus I. So the next point is this one. So the first pole is this one and the second pole is this one. Minus 1, sorry, this is minus 1 plus I. So this is minus 1 and this is plus I. The second pole is this one. And the third pole is minus 1 minus I. Check here, minus 1 and this is minus 1. So this is the third pole. And this one is 1 minus I. So the 1 is here and minus I is here. See? So these two are outside and these two are inside poles. So inside poles are nothing but, see, the first one is 1 plus I is within. So 1 plus I is within the pole, and the next pole here is minus 1 plus I. So this is minus 1 plus I is also within the pole. So this pole is nothing but A into e power, that is I pi by 4, and this one is A into e power, this is I times of, this is 3 pi by 4. These two poles are inside and these two poles are outside the pole, outside the given contour. So this one is A into e power, that is I 5 pi by 4, and this one A into I power, this is a 7 pi by 4. So these two, so we have to calculate the residues. So out of these poles only A into e power pi by 4i and a into e power 3 pi by 4i lies within the contour, and both are simple poles. So we have to find out the residues for each and every pole here. So for finding the residues, what we have to do, as they are simple poles, the first thing here what we have to do is, the first pole here is z is equal to a into e power I pi by 4. For that, what I am going to do, this one is residue of f of z. At point z is equal to a into e power, this is I pi by 4, is nothing but, this is limit z tends to a into e power, this is I pi by 4. So this will be z minus a into e power I pi by 4 by, what is our f of z? That is z power 4 plus a power 4. So if I substitute, so this will be 0 by 0. So I have to apply L'Hospital's rule. So after applying L'Hospital's rule, so this will be limit z tends to a into e power, this is I pi by 4. So the derivative here in the numerator is 1 and the derivative here is 4 into z cube. So I am going to multiply z on both sides, both the denominator and numerator, that is a into e power I pi by 4. So z, with z I am multiplying, that is 4 into, this is z cube, and now I am going to substitute this one. So here if I substitute the z value as this one, what is our z value? That is a into e power I pi by 4 by 4 times of, this is a into e power, that is I pi by 4 power, this is 4. 4 got cancelled, and this value will be a by 4 times of, this is e power, this is I pi by 4, and see here. So this will be 4 here will be. So this is a power 4 into e power, this value is I pi. I pi. So if I cancel this for one time, so this will be 3. So this is e power, this is I pi by 4 by, this value is 4 a cube, and this is I cos pi plus this value is I sin pi. So cos pi value, see, as you know that cos pi value is equal to -1. If I substitute, this will be I pi by 4 by, this is 4a cube into -1. This value is -1. So here the residue value of f of z at point z is equal to a into e power I pi by 4 value is nothing but minus e power, this is I pi by 4 pi, this is 4a cube. Clear? So this value is, so this is the pole value and this is our residue value. And the next residue value here is z is equal to, see, coming to this, z value is equal to, z value is equal to a into e power I into 3 pi by 4. And now again we have to find the residue for this. For finding the residue, as it is a simple pole, so what we have to do, so residue of f of z at pole z is equal to a into e power, this is 3 pi by 4 is equal to limit z tends to, that is a into e power I 3 pi by 4. This is z minus a into e power, this is I into 3 power pi by 4 by z power 4 plus a power 4. So if I apply this one, this will be 0 by 0. And now according to the L'Hospital's rule, we have to, L'Hospital's rule, according to the L'Hospital's rule, we have to make the derivative in the numerator as well as the denominator, that is limit z tends to a into e power, that is I 3 pi by 4. For z, the derivative here is 1. For z power 4, this is 4 into z cube. Now I am going to multiply with z in the numerator as well as the denominator, that is a into e power I into 3 pi by 4. So with z, if I multiply in the numerator as well as denominator and then substitute the value, see here, this will be a into e power, this is I 3 pi by 4 by, this is 4 times of, this is a into e power, this is I 3 pi by 4 power 4. And the value here is a into e power, this is I 3 pi by 4, and this value is 4 into a power 4 into, this value is I into 3 pi by 4 power 4. So if I cancel this one, so this value, if I cancel for one time, so this will be cube, this is e power I 3 pi by 4 by 4 a cube, and this value is nothing but cos 3 pi plus I sin 3 pi. So as this is an odd pi, the value here is negative. This is e power I 3 pi by 4 by 4a cube into -1, and this value is 0. And see here, now the residue of f of z at the interior pole z is equal to a into e power I 3 pi by 4 value is nothing but minus e power minus 3 pi by 4 by 4a cube. So we got the residues of both the interior poles, that is z is equal to a power a into e power I pi by 4 value is this one, and for z is equal to a into e power I pi by 4 value is this one. Now for the interior poles, the residue value we got, and now we have to use residue theorem. So according to our residue theorem, see here, according to our residue theorem, integral C, this value is f of z into z dz is nothing but, this is 2 pi I times of the sum of the residues of the interior pole. Sum of the residues of interior poles. So what is integral C? As this is a semicircle from minus r to plus r from real axis, and this is the semicircle with center 0 and radius r. So we have to use this curve for this integral. So I am writing minus r to plus r. This value is f of x into dx, plus this value is the semicircle. This is f of z into dz value is equal to 2 pi I times of the interior poles. So what are the interior poles here? Z is equal to, first one is I pi by 4. This is minus e power I pi by 4 by 4a cube. that is minus e power, this is I pi by 4 by, this value is 4a cube, and the next value, the next interior pole is minus e power minus I pi by 4 by 4a cube, that is minus e power, that is I into, this is 3 pi by 4 by, this value is 4a cube. And now if I calculate this one, so this will be from minus r to plus r, this is f of x dx plus integral cr f of z into dz value is equal to, this is 2 pi I times of. So if I take 4a cube common, so if I take minus common from this, so this is I pi by 4 plus e power, this is I 3 pi by 4, the value here is. And now see here, this will be minus 2 pi I. So what is e power I pi by 4? So e power I pi by 4 value is nothing but, see, I'll show you. The value is very clear as, for e power I pi by 4, the value here is 1 plus I by root 2. So you can check there, that is 1 plus I by, this value is root 2 plus e power I into 3 pi by 4, the value is minus 1 plus I by root 2. So this is minus 1 plus I by, the value here is root 2. And now this value is minus 2 pi I. So if I take root 2 common, this will be 1 plus I minus 1 plus I. Now if I cancel this one, so this will be minus 2 pi I. This is 2 pi by, this value is root 2. I square value is, as you know that I square value here is minus 1. So I square value here is minus 1. So this will be minus of minus plus 1. So the value here will be 4 pi by, the value here is root 2, 4 pi by root 2. So this will be root 2, can be written as, this is 4 pi by, the value here is root 2. See here, there is 4a cube remained here, so this is 4a cube. So this value is 4a cube, 4a cube. So if I still cancel this one, so this will be 4a cube. So this is 4a cube. So now I can cancel this one, and this will be pi by root 2 into, pi by root 2 into, the value here is a cube. So this is nothing but minus r2 plus r. This is f of x dx plus integral cr. This is f of z into dz. See, so this is equation number 1. And what is this integral CR as R tends to infinity? So here this is minus R2 plus R f of x dx plus, this is integral CR f of z into dz value is nothing but, this value is pi by root 2 into, this value is a cube. And let us consider this as equation number 1. And coming to this, see here, as R tends to infinity, see, as R tends to infinity, this value I am showing you, this is integral CR f of z into dz. So what is integral CR f of z dz? F of z dz is nothing but z square by, this value is z power 4 plus a power 4. So if I take modulus, see here, if I take modulus mod dz by, this value is mod z power 4 plus a power 4. So which is less than or equal to, this is mod z power 4 by, this is z power 4 minus a power 4. So here is a small substitution. If I keep z is equal to r into e power I theta, then mod z value is equal to mod r into e power I theta. That is mod z is equal to r into, what is mod e power I theta? That is cos theta plus I sin theta. So which is equal to, see, I am showing you mod z is equal to r into root over, this is cos square theta and this value is sin square theta, and mod z value is equal to r. And coming to this, so z is equal to, as we have another point, z is equal to r into e power I theta. We need dz here. For dz, I have to make a derivative on both sides. Dz is equal to r into e power I theta, and again I into, this is d theta. So if I take modulus, So this is r d theta aside, and this is I into e power I theta. So mod dz here is r into d theta by I times of this is cos theta plus this value is I sin theta. And here mod dz value is equal to r into d theta. If I send minus inside, that is minus cos theta, and this is minus sin theta. So modulus in modulus, what happens here? This is r cos theta, this value will be minus sin theta whole square plus cos square theta, which is again equal to 1. Therefore we got mod dz is equal to r into d theta. So we got dz value as r into d theta. So mod z value is equal to r. As it is a semicircle, this r varies from, sorry, theta varies from 0 to pi. And see, now I am going to substitute here, and this value is, see here, what is dz? Dz is nothing but r into d theta. So this value is r into d theta, and this is in place of z, I am going to write as r. So this is r power 4 minus a power 4, and this value is from 0 to pi as r tends to infinity, as r tends to infinity. So here if I take r common and cancel, still there r remained in the denominator. Therefore this tends to 0. Therefore integral cr f of z dz value is equal to 0. And now this is equation 2. And now in this, if I substitute the same thing, this value will be 0. And what remains here, as r tends to 0, so this will be minus infinity to plus infinity. This value is f of x dx by x power 4 by a power 4 value. If I substitute in equation 1, this will be pi by root 2 into a cube. So this value will be pi by, this is root 2 into a cube, and this can be written as 2 times of 0 to infinity. This value is dx by x power 4 by a power 4 is equal to pi by, this is root 2 into a cube. And therefore integral 0 to infinity, this value is dx by x power 4 plus a power 4. I am sending this 2 to this side. This will be pi by 2 root 2 into a cube. See, hope you all guys understand. If you really understand, please, each and every step from the textbook I have explained. So even though it's lengthy, it will be very very helpful for you if you understand and then practice. And definitely for each and every point I have given you a crystal clear clarity, and therefore you can solve by your own. This is the most important question. If you understand this one, please pass it on to your friends, and definitely subscribe to this channel for more videos, and your preparation will be damn easy if you follow these videos. Thank you so much for watching and staying till the end.